So, more of this various, kind of ongoing things. So this is a very interesting piece of equipment. This is, as near as I can tell, basically the primary competitor for our power plug, or E-plug, or whatever you want to call it. This is called the Modlet. It's a similar energy metering outlet. This is a piece of fairly interesting hardware that's it has two problems. It's expensive, it's $50 a plug, and it's fucking cloud-based because stupid. So you get a plug and a USB dongle, but you know what? The USB dongle doesn't work until you sign up with their fucking web service, because they're on fucking crack. It's nuts. Like the local client that it runs doesn't even provide a GUI. It dumps your information to their servers, which then make your information available on their servers as a web app. I mean, just what? Just what? I mean, just it's like the situation where the cloud is the least appropriate solution, and it's like, So I mean, I think they'd probably be a lot more successful if they ditched the whole. You have to use our, your stuff gets uploaded to our servers, which then displays it as a web app because. Anyways, here's a little dongle, blah blah blah. I'm quite interested in knowing what protocol these use, and then here's the plug. So this is fairly interesting. Fuck product registration key. Just the fuck, man. It's just ass backwards. Anyways, as you can see, we have a little USB dongle and the actual plug. These are fairly interesting because, as I understand it, the plugs are actually individually switchable. And then there's a button here which presumably switches the plugs. One thing I've noticed already is Philips, hello, actually serviceable, unlike the Belkin stuff that I just took apart. So, anyways, and then this was apparently supposed to be gooped down in the box somewhere, but the goop came off during the shipping. FCC ID, 5 volts, 80 milliamps, made in China. They claim 30 feet range, which makes me quite curious as to what wireless interface they're using. Also, it's got a hell of a long MAC. This thing may be glued together. I definitely get web services in situations where a web service is convenient. This is not one of them. Or make it an optional extra that you can turn on, but doesn't work without it. It's just stupid. Alright. Okay, I'm already amused. So, I think we are talking Zigbee. Also, FTDI 232. 1 second. So here's our dongle, and you can see that QFN chip arg. You can see, first of all, FT232RQ, which amuses the bananas out of me. Just a standard bog standard USB to serial. And then there's our micro, 25L020, and that looks like Freescale semi to me. Also, look at that big cap, crystal chip antenna, ceramic with a ceramic dielectric. Looks like they had some options for filtering here which aren't placed. So I wonder, this may be a very reasonable Zigbee dongle of some sort, assuming it's constructed the way I think it is, which is basically just like a, I would bet, I don't see how they'd program it, so I bet they're running a bootloader on here somehow. I have a picture of the sticker, I don't need it anymore. So this is an MC13224V. It is indeed Freescale. So I'm betting that's a microprocessor of some sort. So anyways, it's a little chip. There's not much on here. This is just a ridiculously outrageous chip for what they're doing. I mean, they're using what? Probably 5 to 6 pins from the FTDI and 1 for the RF. And yet this is like a QFP64. I mean, just... somebody forgot to cost optimize or something, I don't know. Let's see what's on the bottom side, assuming this thing actually comes out of here. Is it glued in? I think this thing is glued in with frickin' super glue. I strongly suspect this is held together with super glue because if you look at like this white area here, complete with somebody's fingerprints, that looks very much like kind of this mess super glue leaves behind. It's also held in by no visible means. Oh, there it goes. Okay, back side of the board. Nothing. Think Eco Dongle Rev 1. PLOTECH. And a big ground pour with lots of vias. So those vias are all to make this, so this is an RF transmission line, whatever the characteristic impedance of this board is. This is also not a, it's probably a 50 ohm transmission line, and this is not a 1.6 millimeter 0.064 inch board. It looks like it's a 0.032 or something along those lines, actually. Dropping cables on myself. This board is a 3.036, so it's probably 0.032 without the copper. Let's measure down here. Yeah, well, so the solder mask is probably a significant portion of that. So this is indeed a half thickness board. So this is also, the solder mask is also included in that. So one of the reasons they probably went with the 0.032 inch board, the 0.8 millimeter board, is because for having a 50 ohm transmission line, which I would bet that's what this is, because 50 ohms is just kind of the industry standard. So when you have a 0.064 inch board and your transmission line's on the top side and your copper pore's on the bottom side, the width for the proper characteristic impedance is large. It's like 40-50 mils. And that's basically not possible to route into a chip which has a pitch that's significantly smaller than the width of your transmission line. So you wind up with a very narrow, unmatched portion, or, just all sorts of other problems. So another thing, actually, I'm just noticing is that I think this is a 4-layer board. Because if you notice right here, a bunch of things come out, and then there's a via there because there's no other reason that would be there. Then if we flip over, that via ends to land on the bottom side. And that particular copper layout pattern would make no sense unless there's an internal layer, which is also somewhat supported, by the fact that this is not transparent. So I bet this is a 3 or 4 layer board. I just noticed this. Look at this, very interesting. So they grounded the shield of the USB, but they're careful to basically return all these currents into the center here. That's a nice layout touch. I'm actually quite impressed by that. And it shows that somebody there knew what they're doing. I mean, I bet the people who laid this out were decent engineers. Let's, hang on, let me change lenses again. I mean, the nice serpentine trace for the RF makes me think that the person who laid this out wasn't entirely fruitcake. I'm actually not certain, because how many layers this board is. Because look, I mean, the area under the antennas is obviously transparent, where I was thinking it's so dark colored I kind of thought that it might have an internal. So it could be multiple layers. I thought they might have brought the ground out, though I guess that doesn't make much sense. I don't know what the antenna requirements are. But I'm not sure how many layers it has. My guess is more than 2, but I could be wrong about that, and I'm just basing that on the fact that there are vias that seem to go through for no reason. Though I guess those could also be used for, well, the only other reason you'd ever have a via like that is to hold the copper onto the board, in situations of mechanical stress, and I don't really see that happening here, so I don't know. But it's just a kick that it uses just a really rather enormous freescale micro CPU. I think that's probably a full-blown processor. It uses a Freescale, CPU and a FTDI FT232R, and then it looks like it was super glued together by somebody. So this may be a very interesting, my bet right now is it's Zigbee, though I have to look up the part numbers for the microprocessor. Anyways. So, first comments on the actual outlet. This is a very nice piece of hardware. It buzzes a little bit, but it's very solid. I mean, no creaks. It feels like this is probably like at least 1/8 inch thick plastic. It's a very decent piece of equipment. Other things, like if you look at the plugs, these are solid brass. Compared to something like this, this is the Belkin device. You can see how the ground plug, I mean, if you compare these two, the ground prong on this Belkin, this very inexpensive Belkin, is a piece of folded sheet brass, from the look of it. And you can see the spade lugs are, well, this one's folded sheet brass and that one's solid. That's kind of intriguing. So the neutral solid, go figure. But I mean, so that's folded sheet brass and this is folded sheet brass, whereas here we have solid brass, and then these are just great big solid brass tines. Definitely higher quality. I mean, I don't know to the extent to which that's actually really needed. Other things. It actually uses Phillips. So these look to be sheet metal screws. I mean, there's nothing wrong with using sheet metal screws in plastic, though. You can buy special screws with thread profiles designed specifically for going into plastic for not much money more. Though I guess they're just not very widely known about. I didn't know about them until one of the places I was working before I decided to start using them, and I'm kind of like, hey, those are cool. And the thread profiles on plastic screws are definitely slightly different. Actually, are these... And these don't have anything interesting with regard to thread profiles. Anyways. Wow. This sucker's busy. So here is our so here's our actual plug, and you can see this is the ground tines kind of wobble a little bit. So this has monitoring on a per plug basis, as I understand it. It's also, so here is our power supply, and if I am not mistaken, this power supply is based on an LNK302, which is the same device I'm using, probably because they're really common. So, also, you can kind of, just an initial overview, you can see here are your two current shunts. Power comes in here, goes through these, screw down to the PCB terminals. That's quite nice. Looks like this relay switches this outlet, this relay switches this outlet. These are SCHRAK branded relays, 5 volt DC, 16 amps, 250 volts. So they're certainly rated for it. So here's our LNK device. Power comes in through initial surge limiting resistor, diode, capacitor, LNK, output capacitor. Here's the switching device. Don't know what that is. It's a little tiny funky 4-pin package. But then look closer. There's the power monitoring IC. This is a CS5487, which is a 3-phase energy monitoring IC that can also be used for just measuring multiple. It can also be used in a situation where you just want to measure a couple different, power consumption in different sections. It doesn't have to be set up at the 3-phase. I can already see that it looks like they have proper Kelvin connections here, proper Kelvin connections there. It's interesting that they've left the crystal for this device off. I didn't know that was possible. They may be generating a clock in the microprocessor, which is this device here, to run the Cirrus device. We have a PCB trace antenna. Let me take this further apart, and then we will switch over to macro. This board should just lift off, yep. Then here is the grounds. So one thing you can notice here is the grounds are proper dual tab things, so that basically the probe sits in the middle, which is the proper way to do it, because you have more contact area. It goes in, you know, kind of like that. Whereas with the Belkin device, it just one side rides against plastic and the other side just has a single wipe. So this is double wiping is the proper, I believe, the term for it. You can see these brass things, and then they're swaged in, which basically means there's a, or riveted, I guess is another way. So there's just a pin poking up, and then they just smack down on it, and it mushrooms out at the top, and then that causes it to balloon, you know, basically balloon out, and, you know, it's kind of cold roll, I think, if it's done properly. Anyways, one second. Alright, so here we are. So there's the energy monitoring IC. It's a CS5467, sorry, not a 5487. It's an older model chip, I think. And I still don't know how they're clocking it, considering that, I mean, as you can see, there's no crystal here. It looks like there's space for a solder, the space on the solder mask and everything. So you can see, here's the, this is actually the hot, I believe. Yeah, that's the hot side. So this appears, wait, really? I have trouble believing that. They're switching neutral? Really? Big terminal's neutral. That's weird. So a couple other things of interest. Wow, look at that. They have two completely independent resistor divider chains. Why the hell did they do that? I have to look at the data sheet. So my guess would be that this is kind of a dual energy monitor and it needs two voltage inputs. But yeah, so this is, you know, this is straight out of the serious, you know, the CS Devices data sheet. I did something very similar, only I actually added a fifth surface mount resistor. I'm using 12062. It's interesting. It's kind of affirming to see a commercial product doing exactly what I have done in my design. So you can also see here, this looks like this is probably, it's marked RV. So that may be no, then there's a fuse in line with it. They're switching the neutral, that's wacko. I mean, other weird shit here. I don't know what this is. My guess is this is a, it's marked RV. My guess is it's a MOV, but it's got a fuse in line with it. That completely negates the entire point of a MOV. It's got a 1 amp bus fuse in series with it. I don't know what the fuck that's for. You know, I mean, it's across the line. I mean, here's one line terminal, here's the other. And there's a fuse, and it's either a Y cap or a MOV. But in either situation, the fuse ain't going to do squat. It's not going to do anything because it's fused. It's not like they're fusing the outlets, they're fusing the fucking protection mechanism. So rather than damage the protection mechanism, which is what it's for, they'll blow a fuse in and blow up whatever's connected to it. Wow. Just wow. You know, so R002. This is funny. This is, like this capacitor network here. Exactly. All of this is a verbatim copy of the reference design. This is a complete exact copy of the reference design. And these, I can actually tell you that these two capacitors to ground are probably 220 picofarads. And this is and this cap here is 0.022. It's 22 nanofarads, or 2.2 nanofarads, I can't remember. You know, and then this is probably, I don't remember what these are. Oh yeah, this one's 0 ohm and this one's 1K, I bet. Because that's what they are in the reference design. Like this value, 0.002, reference design. So that's going to be probably a 3.3 volt LDO. I don't know what this is. It appears it's tied into the error amplifier somehow. That may be an opto. Okay, there's not very much written on an A217. Let's see what I can find. Being 2 pins though. You don't need an opto for this. It's a non-isolated power supply. It may just be to let them toggle the system on and off or something along those lines. Another thing is this normally wants another feedback capacitor that I don't see. A lot of this is very, very straight off the reference design. What are these capacitors? 4.7 microfarads at 25 volts. Like the reference design for the LNK 302, which is what I bet this is, and maybe a 304 or 5. It's a 304. So the reason they need a fair amount of power supply, I mean, I only have 2.2 nanofarads, and that's probably grossly overkill. I mean, our circuit, you know, we need about 2.2 microfarads. We need 1 microfarad of capacitance, you know, to run the link without having any, you know, dropout issues, because we're not running relays. It's actually interesting. I mean, all this electronics in the version of this that I've designed needs about 15 milliamps, whereas the relays want like 30 each. So this, you know, they probably need about 60, 70, 80 milliamps to run their whole circuit. All of, 90% of which is running the relays, which means they need a lot more bulk bypass capacitance for the LNK devices. This is just a big flame-proof resistor, which doubles as a fuse and an inrush limiter, though there's a fuse here. You can see, here's our neutral input. Again, they're fusing the neutral. They're fruitcakes. I mean, unless I've got the lines hooked up backwards, but if you look here, the big tab in the American plug is neutral, small tab is line. So this is neutral. The fuse is in line with neutral. This whole thing is hot referenced. I have no idea why. It's nuts. I mean, actually, one of the things is, I know why. It's because that's the way the reference design is. I flipped mine around. Mine is, I flipped the reference, my implementation of the reference design around. It's now neutral referenced, and yeah. So I guess they just weren't adventurous or something. S1M049, just probably a service mode diode. One of these diodes, this is a fast diode. It has to be a fast diode for the switch mode converter. I bet that's 3.3 volts because this needs 3.3 volts, and I bet this does too. So that is very much, my money's on it, actually. SST25VF04. Oh, that's a flash IC. So this and this look to both be positions for flash memory. Probably because they've got a whole bunch of really complicated crap going on here, and they need a lot of SRAM space. You got a bunch of LEDs. I bet D8 or that's a diode. U8 and U9. Some of this is going to be switching for the relays. Yeah, it's actually interesting. You can see that here's one of the relay terminals and here's the other one. You can actually see this appears to be just a 2-layer. No, this is at least a 3-layer board. Yeah, because look here, you can see there's an internal plane there. Wait, maybe not. Yeah, like that pad there, there's nothing on the top layer, there's nothing on the bottom layer, and yet there's that dark line there. So I bet this is, I believe, a multi-layer board, a many-layer board, more than 2 in any event. But yeah, you can see that here's one of the relay terminals which runs up here. You can see this slightly heavier trace. Man, look at the micro vias on that sucker. Runs over to these transistors here. I'm not sure. These may be... I don't know. These may be bistable relays, which basically means they only need to pulse them, because I don't know why they would have because if you look here, you can see that there's two switches right immediately proximate, and then there's two diodes. Actually, so this is an amusing widget I made last week when I need to do some precise probing. This is a pair of tweezers with a test lead screwed through a, lugged onto the end, so that you can basically use your tweezers as a very precise probe. It works well. It's just amusing. So, what I'm doing now, oops. So I bet these two terminals are connected together. Yep. Now let's see if this is connected to the central terminal of the relay. Okay. No, it's not. Interesting. So, that central relay terminal must be... Well, this whole thing is let's see, is it referenced to the neutral? No. So, is it referenced to the output of the LNK, which is going to be there? Okay, so the output of the LNK, the unregulated LNK output, runs to the central terminal of the relay. And then my bet would be that, since this whole circuit is neutral referenced, oops, that means I need to clip on to the neutral. And then, so, that's probably hot, yeah. And then this is ground, and this is ground. So, is this pin point here connected to the relay windings? Yes. Oops. So of course I could always look these relays up. That takes all the fun out of it. Yeah. So this goes to one pin and this goes to the other pin, and then these two, I believe, both go to probably VCC, which is not easily accessible. Oh, there it is. There's VCC. Yeah, so it looks like they're using bistable relays. So what the deuce do they need the giant for? Because with an LNK302 and with much less capacitance, you get plenty of power because they don't need to run the relays all the time. I mean, how much current can this silly microprocessor draw? You know, I mean, the Cirrus is probably 3 to 4 milliamps, and this is maybe 10. And you can get, you know, you can then run, I mean, even if it's 20, you could run that all off 2.2 mics of input capacitance, and you don't even need the series filter, probably. You know, just other weird shit, like just, I just don't understand why they have two of these voltage dividers when they could probably feed the same input into both of the ADC channels without any issue. You know, or why are they using both two ADC channels for the same voltage? This is another MC13224. You can see we have a little clicky, there's our button, U14, U15. I wonder what, I mean, there's all these passives, and, well, and all of these, you know, LEDs, and look at all the resistors, and same exact antenna layout. So they're using a PCB layout antenna on this one. But yeah, just the Cirrus device, an LNK304, some fancy diodes, big power series resistors. This fuse that just confuses me. I mean, I don't... Why would you fuse what can only be the protection components? And that is a K150. 100K, 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 100. So they did play with the values a little bit. That should be 422 instead of 400. But it's always possible they have another divider over here. I mean, the board is beautifully laid out. I mean, like some of these, like you see the lines running to the capacitors or the resistors. That's really good layout there. I mean, some of this, I mean, it's interesting how they have different trace sizes. And there's obviously been a lot of care in here. This is going to be JTAG of some sort. Got a big crystal, 24 megahertz crystal. I just don't understand some of the design decisions. Because, I mean, they make no sense. And this is Rev 3. Now you can see this is how this is, I mean, you can see that this goes here, goes into the relay, comes out and goes to this pin. That fuse runs like that. Runs across the inner layers, runs through the fusible resistor, capacitor, inductor, capacitor into the okay. Think eco. I mean, all the brass, the shaped brass is beautiful. It's just, it's like they dished out all the money in the wrong areas almost. I'll have to look up this device, I don't know. I mean, it may boot off of this external flash, but that's a 25 VF040. That's like a megabit of memory, I think. It's a lot of space. What do they need all that storage space for? Anyways, back into the case. I mean, this, I certainly can't complain about their mechanical engineering. Well, I mean, this is really beautifully done. It's kind of spectacular overkill in some ways. Like, you know, I don't know what their goals are, but they could probably squeeze a significant amount of money out of this just by doing a little optimizing without too much work. I mean, this is kind of, it strikes me very much as like a reference design type thing rather than something that's an actual product, because it's just, I don't know. Yeah, I mean, like, assuming that this has some good, you know, 12 or 14-bit ADCs, you can dump the Cirrus entirely, which is what we're doing. You know, so on and so forth. And you've got this big, complicated button assembly with lots of LEDs. You know, I'll probably try and use it. Let's see why not to. Kind of a pain in the ass to have to deal with all that stupid shit about their goddamn software. Be interesting to, like, if this uses Zigbee, which my guess is it does, be interesting to poke at it with another Zigbee device that's, you know, open source, like a Zigduino or something. Well, I just plugged it in, as you can see, it's got like all the fancy swooshy lights. And also, it comes up a little fast and it kind of slows down. And the other thing I was thinking about is that, you go back on the tripod, is that this thing has a rated maximum current draw of 80 milliamps. So, I mean, that could explain why they need all that power, because the, you know, whatever semiconductors they're using are really power hungry. But that seems like a really bad design choice. Maybe they just had somebody who knew that Freescale chip and nothing else. Weird. Anyways, I'm going to see if I can get this thing working. So here's kind of a silly aside. So a lot of these things have this great big, you know, ghastly, horrible, you know, end user license agreement that I always have trouble with. You know, probably a lot of these are like, we want your credit card. What the fuck do they need my credit card for? I bought their hardware. You know, you can't reverse engineer their shit, blah, blah, blah. Well, oops, I'm reverse engineering it. So one of the things I like to do is you use like a debugger. I use Cheat Engine just because it's really easy to use. You know, basically, it's intended for games where you want to tweak values, you know, in memory of another process, you know, for cheating. But it lets you do fun things like search through memory for, you know, strings and so forth. So you just hook into the installer, and you search for, like in that situation, I searched for accept and replaced it with derp. So I will definitely agree with the fact that I derp, but in no way am I agreeing. So that's kind of a fun, silly way to basically de-wrap the click wrap without actually ever agreeing to anything. Oh, shut up. So, you know, obviously I'm doing this in a VM because I don't want their shitty software all over my computer, and it'll stick its drivers in interesting places and God knows what. Yeah, anyways, just that's kind of a funny aside in a way to get around click wrap. You know, I've never really understood how. I mean, I don't think that sort of thing, you know, like a click wrapper like that, where it's my understanding that the checking of I accept is kind of the legally binding aspect of it. It's like signing. I don't think it's ever really been tried, but I've never really understood how it's enforceable because the company has no way of knowing that it actually properly presented it to you. I mean, self-evidently, you can edit the values of what's being shown on the screen without affecting the process, you know, the system. You know, and I did this with, you know, a piece of software you can download off the internet without any trouble. Okay. Also, another thing I have going here is I have, where is that folder? Sorry, I'm derping around on Stack Exchange. I spend a lot of time on Stack Exchange. So I should have, so I'm running VMware, and because one of the things you can do is turn USB logging on, which I've done, so you can see what it's actually doing is I'm actually not entirely certain what the hell that is, but you can see that it's basically saving all of the USB data packets that it sends out over the USB interface as hex, and they have some tools for analyzing these files. But that means that later on I could probably go in and I'll have information if I want to do anything. I don't think I'll ever really bother reversing this stuff, but it means I have the information in any event. So, you know, the usual stupid shit. I'm configuring the hardware on my computer through their stupid-ass web interface. I mean, just, like, why? Why would you design any sort of system like that? So the system, it timed out searching, so just have to replug it. Now it's fine, so have one of them. I don't want to have to put the frickin'... I can't do anything without their shitty web shit. I don't give a fuck about the appliances. I just want to switch the fucking outlets. So how do I do anything with it? Okay, great, I've configured an outlet. So how do I turn it fucking on? So it's supposed to be switchable. Where are the switches? So there's no actual control over it? It just tries to... How does the model through smart scheduling, ergo fuck you and your desire to actually have manual control? So there's no way to actually turn the outlets which are switchable on and off manually. You have to let their stupid shit scheduling shit do it all automatically for you, except when it fails. Ooh, appliance types. Well, what does that mean? Oh, you need to wait, you can't... You have to use the fucking... It does not have surge protection. The surge protection is fused. Many energy-efficient ovens have a long payback period to push assurance them. This is the case of Modlet 2. No, the Modlet typically pays for itself in 6 to 12 months. That's a long payback period. Unless they have a completely different... So apparently, despite all their stupid-ass, swooshy web shit, you can't just go and turn your frickin' single appliance on or off. This is, without a doubt, one of the most poorly designed... I mean, they have one, you know, they've come up with one usage profile that one dude somewhere fits. And if you don't fit into the usage profile they've designed their software for, you're fucked. It's just... I mean, this is... I mean, it's horrible. I mean, I don't know what the fuck they're thinking. They're nuts. I mean, they have all this work to design all the system that... I want it to fucking end now. I don't give a toss about my baseline energy usage. Oh, I see. You can turn... So you can set up all fancy schedules that turn things off when you're not there. Well, where is the button that says fucking on and fucking off? I mean, this thing's $50. Alright, I give up. I'm just... It's a lost cause. This is just, without a doubt, a flaming turd. Don't ever buy one of these things. They're shit.